Good morning to everyone. So this is S. Naguldev, Assistant Professor, Department of Chemical Engineering, Hindustan College of Engineering and Technology. So today I am going to discuss about the topic of pool boiling, which comes under the subject at heat transfer. Okay, wow. So pool boiling is nothing but as a concept of heating the water in a vessel. Okay, wow. So this is the graph which I have shown there, and this pool boiling will be divided into your four parts. One will be your natural boiling, nucleate boiling, transient boiling, and flame boiling. Okay, wow. So just imagine you have a beaker which consists of a water, and I'm going to heat that water. So what happens? First of all, the surface will get heated, that we call as conduction. Then the water will get heated with the help of the fluid movement, that we called as convection. Okay, wow. So that's the same concept I have drawn in the graph. Your natural boiling, it indicates you're going to heat the water in a vessel. Your water is going to be get heated. So that is the purpose of the natural boiling. Then coming to the nucleate boiling, the nucleate boiling will be divided into two parts. So see here what I have drawn like this: A, B, and then BC. So this will be one part, and this will be your second part. Okay, wow. So what happens here? See, when we are going to heat the water, okay, the water will get boiled and the bubbles will be coming upwards. But what happens in the nucleate boiling? Suppose if we are having of 100 bubbles, 60 percentage of the bubbles will only the coming to the upwards, and remaining 40 percentage of the bubbles will be collapsed at the middle of the stage. That's why I have split up into two parts: your nucleate boiling and your transient boiling. So your nucleate, this part A to B consists of the all the vapors will not be coming upward. The sum of the vapors will be collapsed at the middle of the system. Okay, and second part B to C, the vapors which are coming upwards, and your all the waters will get boiled and becomes a vapor, and that is your B to C. So A to B, some of the vapors will get collapsed, and B to C, the vapors which is coming upwards, it means that your all the water molecules will be converted into vapor. Then transient boiling, see what happens if we give heat and heat. For example, see the natural boiling, I have the temperature of your 50 degrees Celsius, and your nucleate boiling, I'm just maintaining the temperature of 100 degrees Celsius. And when transient boiling, I'm maintaining the temperature of 180. Suppose I'm giving the temperature as 180 degrees Celsius. What happens? There will be somewhat a layer formed between your surface and the water molecules. So due to this layer, what happens? The heat coming from the surface will not be entrained upwards to the water molecules, because there will be a thin layer formed. That's why the graph will be reduced as C and D. Okay, when we are giving the temperature as 180 degrees Celsius, for example, so what happens? There will be a thin formation of the layer, which will not allow your heat to come upwards. Okay, now then film boiling, it is your DE. So this point, I'm giving the temperature as 400 degrees Celsius. So I'm giving more energy. So what happens? This layer, this thin layer will be formed. What happens is, so here the radiations and convection will take place, in which your radiation will get very heavily, and it will come outside, and it will be attracted to the water molecules, and it will convert your water molecules to the vapor. That's why your graph will again increases. So see the graph. First, you are going to start, you are giving the temperature, your water molecules start to heat, so 0 to A. Then some of the molecules will be collapsed at the middle, that is A to B. Some of the water molecules or the vapor molecules will go up top of the surface, that is B to C. Then what happens again? The layer will be formed at the surface, so the energy will not received by the water molecules for the converting into vapor. So the graph will be reduced from C to D. And then again, the giving high temperature, giving a high energy, the radiations will take place. Okay, and the graph will increases from D to E. So this is the concept of the pool boiling, which is just heating the water in a vessel. Okay, thank you.